guys, it's me, Study with Mo, back again. We are going to solve or actually discuss the February-March 2024 paper 062042, paper 4 theory extended for chemistry. Today we're going to do something special. Instead of just the usual solving past papers pattern without anything particular, today we are going to employ a method basically using the syllabus and the past paper simultaneously to take the answers. So, of course, this is just, for direct, for, you know, for students to just see my method of solving it. But in real time, you won't be allowed to take the syllabus. This is why it's very important to memorize, or not to memorize, but to understand what's in the syllabus, and also to memorize some of the things. So, first question. Iron ore contains iron 3 oxide, Fe2O3. A blast furnace is used to extract iron from Fe2O3. Equations from some of the reactions in a blast furnace are shown. Alright, so name the substance which provides the carbon for this reaction. Now we know this is blast furnace, Fe2O3, this is hematite, this is iron extraction. So what we do is search for iron here. Or actually better, carbon. This electrolysis is now a 1. Yes. Alright. The burning of carbon, coke, to provide heat and produce carbon dioxide. Coke. So the substance which provides the carbon for this reaction in the syllabus is coke. So coke it is. Say the purpose of the combustion of carbon in the blast furnace. In front of us it is here, it's to provide heat. Alright. Iron 3 oxide Fe2O3 in iron ore is converted to iron when it reacts with carbon monoxide, CO, in the blast furnace. Calculate the percentage mass of iron in iron 3 oxide, Fe2O3. So here we don't really have uh, the formula in the syllabus, but it is actually manageable to do using your mathematical knowledge. You just do the percentage by mass of the you just do the mass of the desired substance or desired molecule over the whole compound. Compounds MR times 100 gives you the percentage, 70%. Alright, say the name of the iron ore which consists mainly of iron 3 oxide. Simple. Just go in syllabus. Iron extraction. We can just say extraction. Metals, yes. So as you can see here, of iron from hematite. So describe the extraction of iron from hematite. So the name of the iron ore, which consists mainly of iron 3 oxide, is hematite. Describe how carbon monoxide is formed in the blast furnace. So let's see. The reduction of carbon dioxide to carbon monoxide. So how's carbon monoxide formed? It's formed by the reduction of carbon dioxide. It's literally the next bullet point. Write this simple equation to show the reaction that occurs when iron 3 oxide is converted to iron in the blast furnace. So here Fe2O3 plus 3CO is 2Fe plus 3CO2 here. V. Name the chemical process which happens to iron when iron 3 oxide is converted to iron in the blast furnace. And even the answer is really simple, but it's still mentioned in the syllabus. It says reduction of iron 3 oxide by carbon monoxide to give iron. So reduction it is. Say the type of reaction shown by equation 2. Equation 2 is CaCO3, so thermal decomposition. Here you go, thermal decomposition of calcium carbonate to produce calcium oxide. Alright, Explain why the reaction in equation 3 can be described as an acid-base reaction. Let's see if it is here. Stay the main war. Stay here. Let's go to acid-base. Acid. Or chapter 7 because it's the... Let's go. 7. Let's go to the 7th chapter. Alright. Describe the character, describe alkalis. So we don't really have this in the syllabus, but no, we actually do. So classify oxides as acidic, including SO2 and CO2, or basic, including CuO and CaO, related to metallic and non-metallic nature. So basically what this means is that Ca, which is a metal, metal oxide is basic, and non-metal oxides are acidic. So it's literally also mentioned in the syllabus, like as bullet points, so we can, realize the importance of the syllabus in solving any question. So we can say SiO2 is acidic and CaO is basic. State the chemical name of SiO2. Now back to iron extraction. The chemical name of SiO2, it is silicon IV oxide, but we can't really see here. Yeah. The common name given to CaSiO3 when it is formed in the blast furnace. The formation of slag. Basically the last equation. Aluminum cannot be extracted from its ore using a blast furnace. State why aluminum is not extracted from its ore using a blast furnace. Let's see. Let's find reactivity series, potassium, describe the reaction if any of, and explain these reactions in terms of the position of the metals in the reactivity series. So basically, the answer to this is not really that aluminum has an thin, unreactive, protective oxide layer, but it is that aluminum is more reactive than carbon, so carbon won't displace aluminum. Name the process used to extract aluminum from its ore. So we can see here that the main ore of aluminum is bauxite, and that aluminum is extracted by electrolysis. Alright, both iron 3 oxide and aluminum oxide contain metal ions with a 3 plus charge. Write the electronic configuration of an Al3 plus ion. So it's really simple. We go to the periodic table, we flip it so you can see we got aluminum here, aluminum 13, so the electrons are 3 less now, so it's going to be 10. So the first principal quantum shell, maximum number of electrons is 2, so it's going to be 2, and then 8, 2, 8, 10, so it's going to be 10 in total. Alright, deduce the number of protons and electrons in an Fe3 plus ion. Again, we go to the periodic table, we flip it. As we can see here, this is Fe with 26 protons. So it's going to have 26 protons, and since it has 3 less electrons, that's going to be 23. 23 electrons as the answer. Alright. The elements in group VII of the periodic table are known as the halogens. Halogens can form halide ions. Identify the halogen with the lowest density at RTP, room temperature and pressure. It's going to be fluorine. How do we know? Let's check the syllabus. Periodic table. Let's go to subject content. Atomic structure of the periodic table. Okay. Hmm. To number of outer, number of, yeah. Yes, here we got the periodic table, arrangement of elements, described to produce properties, similarities in terms of describe relationship, change, arrangement. All right. Yes, describe the group via halogens, chlorine, bromine, and iodine as diatomic with general trends down the group limited to increasing density, decreasing reactivity. So if it's increasing density from up to down, that means from up it has the lowest density. And as we can see in the periodic table, that is going to be fluorine. As you can see here, fluorine is at the top. So that is our answer. Alright. State the appearance of bromine at room temperature and pressure. State the appearance of the halogens at room temperature and pressure as bromine, a red-brown liquid. Literally there. Word for word. Use a periodic table to give the symbol of the halogen with the highest atomic number. We go to the periodic table, we rotate, and we find that TS tennessine is the one at the bottom. So as an atomic number of, we don't know the atomic number. The atomic number is going to be 117. Atomic mass, we don't really know the mass, so that is going to be tennessine. Deduce the number of occupied electron shells in an atom of this element. So to deduce the number of occupied electron shells, it is going to be it depends on the period number. As you can see here as an arrangement of elements, describe the relationship between group number and the charge of the ions formed from elements in that group, and yeah, give information about the elements. Where is the periods? Oh, not here. Yes, guys, there is actually a relationship between the period that an atom or that an atom that an element is and the number of occupied electron shells in an atom of the element. So it is going to be 7 because its period is 7. As you can see here, tennessine 1 1 starting from hydrogen 1 1 2 3 4 5 6 7. So 7 is going to be the number of occupied electron shells. Let's rotate. Alright. Say what is meant by the term covalent bond. A pair of electrons is shared between two atoms. You can search for it here. Covalent. Formed when a pair of electrons shared between two atoms, leading to noble gas electronic configuration. Alright, name one halide ion which bromine molecules can displace. So let's go to periodic table. Periodic table. Down, 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 down. Yes, we are here. Decreasing reactivity. So that means the elements higher in group 7 are more reactive than the ones below. So iodine is less in reactivity than bromine because it's at the bottom. So explain why bromine can displace the halide ion in DII. Bromine is more reactive than iodine. Name a halide compound which can be used to detect the presence of water. Anhydrous cobalt 2 chloride. Can also search for this water. We search for water. We can get the yes, it's here. Including CuSO4 and COCl, COCl6H2O. So COCl6H2O, but here it's anhydrous, so it is without the 6H2O, COCl2. Anhydrous because it hasn't contacted with water, and we want to know the difference. Halide because it contains chloride. So if there's no halide, we can do COSO4 or COCl. Alright, calcium chloride is an ionic compound. Complete that dot and cross diagram in figure 2.1 for the ions in calcium chloride. Give the charges on each of the ions. So Cl minus, Ca2 plus, Cl minus. It's Ca because it has two outer electrons, two outer shell electrons. Cl because it has one so because it needs one more outer shell electron to get 8. Aqueous lead-2 ions are added to aqueous chloride ions. A white precipitate of insoluble lead-2 chloride, PbCl2, is formed. Name a lead-2 compound which can be used in this reaction. That's going to be lead-2 nitrates. Lead-2 nitrate, guys. Remember to memorize your solubility table. Here, nitrates are all soluble. So since it said aqueous, so it needs to be soluble. So lead-2 nitrate. Write the ion equation for this reaction. Include state symbols. That's basically going to be the Pb2 plus, lead-2 plus, and 2Cl minus to form the precipitate. We don't want any spectator ions because it is an ionic equation for this specific reaction. Name one other insoluble chloride. That's going to be silver. How do we know that? Chlorides are soluble except lead and silver. Alright, the question is about acids, bases, and alkalis. So define the term base. So it's literally, bases are oxides or hydroxides of metals, and the alkalis are soluble bases. But here, since we're taking supplement, we're gonna say bases are proton acceptors because it said define, not state. So we're gonna say bases are proton acceptors. Say what is meant by the term alkali. They are soluble bases. Alright. Thymophthalate is an indicator. Say the color of thymophthalate in NaOH. NaOH, we know it's an alkali. So that's going to be blue. CH3COH is an acid, so it's going to be colorless. Use the information table 3.1 to identify the substance with the highest concentration of H plus ions. Explain your answer. Substance is HNO3. Why? Because it has the lowest pH. Alright, name an indicator which can be used to identify the substance with the highest concentration of H plus ions. We know that the universal indicator can be used because the syllabus says describe how to compare hydrogen ion concentration, neutrality, relative acidity, and relative alkalinity in terms of color and pH using universal indicator paper. So that is a clue. Complete the equation. Show the dissociation of ethanoic acid CH3COH in aqueous solution. So CH3COH aqueous to CH3COO minus plus H plus. How do we know that? This is the equation right here. Write the ion equation which represents a neutralization reaction between any acid and any alkali. Here it is, H plus aqueous plus OH minus equals to H2O. They didn't really need they didn't say include state symbols, but if you want, it's alright. Dilute nitric acid HNO3 reacts with aqueous calcium hydroxide CaOH2AQ. It's shown 2HNO3 plus CaOH2 2SCaNO32 2H2O. Calculate the number of moles of CaOH2 used. First, you convert from centimeter cube to decimeter cube. So unit conversion here is key to not making mistakes. The importance of unit conversion here is really crucial. So we get our number of moles and determine the number of moles for HNO3. HNO3 are basically to CaOH2 is a 2 to 1 ratio, so we multiply by 2 to get the HNO3 moles. 0.0006. Calculate the concentration, we just do moles over the decimeter cube, 0.024. 0.024 times 63 is going to give us basically the AR of HNO3. That's going to give us the MR of HNO3. That's going to give us the 1.512 grams per decimeter cube. The equation for the reaction between methanoic acid and ethanol in the presence of a catalyst can be represented as shown. X represents the ester formed. In the equation, methanoic acid is represented by the formula HCOOH. Name this type of formula. That's going to be structural. Just to be sure, maybe it is mentioned in the syllabus. Let's see. Yes, structural formula is ambiguous, including CH2 to CH2, CH3. So this could be a clue. So we could say structural because of this. Write the empirical formula of methanoic acid. Let's see empirical, where empirical is mentioned. Find the empirical as the simplest whole number ratio of the different atoms or ions of a compound. So we can use this to determine the methanoic acid's empirical formula, which is CH2O2. Name and draw the display formula of ester X. So ester X, to name it, il is the first name is going to depend on the alcohol. The second name is going to depend on the carboxylic acid used. So here we used ethanol and methanoic acid, so it's going to be ethyl methanoate. Split formula, we remove the H's and OH's because, as you can see here, H2O is formed, so it is acid-base reaction. The reaction is reversible and reaches an equilibrium within a closed system. Say what is meant by the term closed system. Again, just search. As you can see here, really nothing. This is, a question which needs some critical thinking. A closed system is basically where nothing can enter or leave the system. It's not mentioned in the syllabus, but it is manageable to explain. State two characteristics of an equilibrium. Here, rate of the forward reaction is equal to the rate of reverse reaction. Concentrations of reactants and products are no longer changing. So this is a really simple way of determining the answers. Complete table 4.1 show the effect of any on the concentration of X at equilibrium for each change of condition. So change of condition, temperature is decreased. We can see an increase. Why? Because of the enthalpy change here. It's negative, so that means the forward reaction uh, depends on the low temperature. So if there's a lower temperature, there's a higher concentration of the products than the reactants compared to the reactants. But of course, the overall rate of the reaction still decreases if the temperature is decreased. So still it's increased, concentration of HCOOH is decreased. Since this decreases, Le Chatelier's principles say that for every reaction there is an opposite reaction. Basically, in chemistry, what that means is that if something changes in some side, the other side will give a counteraction to counterbalance the change. So if the concentration here decreases, the concentration here will also decrease to balance it. Concentrations of both H2OH and CH3CH2OH are decreased, it also decreases. The catalyst is removed, there is no effect. Butane and but1ene are colorless gases at room temperature and pressure. suggests why butane diffuses quicker than butane. Why? Because butane has a lower relative molecular mass. How do we know this? Let's search up diffusion. Describe and explain the effect of relative molecular mass on the rate of diffusion of gases. So if there is a more relative molecular mass, that's going to diffuse slower, but butane has a lower, so it's going to diffuse faster. Identify the products formed when butane undergoes complete combustion. So let's see complete combustion. So carbon dioxide from the complete combustion, and let's see if there's another mention. There is another mention. Incomplete combustion. So incomplete combustion gives carbon monoxide, but complete combustion gives carbon dioxide. See again. Not alkalis, alkanes. Alkanes. Let's go to alkanes. So we can see the like many information here, but we need one that proves combustion. Describe the combustion of ethanol. No, wait. There is actually one. Let's search again. Carbon dioxide and water. Describe photosynthesis. Uh, no, we didn't really see it. Reactions, alkanes. No, no. We cannot. There should be one. There should be. There actually should be I think a bullet point that defines or says that carbon dioxide and water are uh, formed from combustion of alkanes. Uh, so that is the answer actually. Carbon dioxide and water are the products formed when butane undergoes complete combustion. Alright, so one molecule of butane reacts with one molecule of chlorine in the presence of ultraviolet light. During the reaction, one hydrogen atom in butane is replaced by one chlorine atom. Name the type of reaction which needs ultraviolet light. So let's search here ultraviolet light. So this is as a photochemical reaction with chlorine with ultraviolet light. So this is photochemical. State the purpose of ultraviolet light during this reaction. In the same sentence, provides activation energy. Name the type of reaction which takes place when one atom of chlorine replaces one atom of hydrogen. In a substitution reaction, one atom or group of atoms is replaced by another atom or group of atoms. Determine how many different structural isomers can form during this reaction. Remember, butane can only form two different structural isomers. Butanane, butane, butane forming with chlorine. So it's gonna be either one chlorobutane or two chlorobutane. So those are gonna be the different structural isomers. When butane reacts with steam, two possible products form. Identify the type of catalyst which is used in this reaction. We can use the syllabus again to determine what are the products. Let's go here. Catalytic addition of steam to ethene. When steam to ethene at 300 degrees Celsius and 6,000 kPa in the presence of an acid catalyst. So it doesn't really matter if it's ethene, butene, it's still an alkene. So it's an acid catalyst. This is the type of catalyst mentioned in the syllabus. Name and draw the display formula of the two possible products. Here, unfortunately, you can't really see the possible products, structural isomers, or displayed formula in the syllabus. So that is you have to do it without the syllabus. So that's gonna be butane 1 ol and butane 2 ol. because there are only two different structural isomers. The OH on one carbon, carbon 1, and the other one, the OH will be on carbon number 2. Butanene undergoes polymerization. Say the type of polymerization that butanene undergoes. So we go here, we search alkenes. It's literally here, alkenes. Include, describe the manufacture of alkenes, describe the reasons, say that in addition, describe the properties or draw. So say that in addition reaction only one product is formed. We want polymerization. Where's polymerization? Describe the formation of polyethene as an example of addition polymerization using ethene. So yeah, basically say the type of polymerization butanene undergoes. We use the same principle of ethene, of any alkene actually, for any alkene for butanene. So that means butanene also undergoes addition polymerization. Alright, when it comes to drawing the part of the polymer molecule to show the three repeat units, we first draw the whole molecule, then we make a number of brackets. We make some brackets around here. The functional group, C double bond, and then we gather the remaining C's outside. We gather the remaining atoms outside, and put them to the one that is empty, that has an empty slot. Or even if it doesn't have an empty slot, we just add up all the atoms there, and we close the brackets. We get the double bonds out, so it can be branching like arms, like here. And then we do this multiplied by 3, so 1, 2, 3. Don't forget the branching arms because it is only 3 repeat units. It's not the whole molecule. So here we are showing that these are just repeat units. It's not the whole molecule. And this is the end. We have finished this paper using the syllabus. And as you can see, the syllabus was actually really useful here. We managed to solve over 70% of the questions just using information directly from the syllabus, which is really helpful. So this paper was actually like fairly easy using the syllabus, and it had some questions which couldn't really be solved using the syllabus, like the closed system definition question, but was fairly simple, like nothing enters or leaves the system. And we had some trick questions, like name a halide compound which can be used to detect the presence of water. We could have said hydrated cobalt 2 chloride, which is wrong because we want to test the presence of water. Or we could have said copper 2 sulfate instead of cobalt 2 chloride, forgetting that it actually needs a halide compound. Also, ones for the solubility tables, this needs serious memorization for the solubility tables. Nitrates are all soluble. Sodium, potassium, ammonium ions are all soluble. To find the term base, these are simple questions. Yes, mainly it's just really simple. And for the final one, for just do the units, for the last question, here calculate the concentration of HNO3 in grams per decimeter cube. They could play with the question. So instead of trying to memorize the formulas, try to play with the formulas and try to play with the units. For example, moles per decimeter cube times grams per mole. Grams per mole is MR. So this is how we got the grams over decimeter cube, because the mole down and the mole up will cancel each other. That's gonna be 1 over decimeter cube times mole times gram over 1. So that's gonna be grams per decimeter cube. Here as well, it's really just the syllabus knowledge. When B1 in as a lower relative molecular mass, acid, Yes, it's really fairly simple, just a drawing part where you need to practice, and that is it. Thank you very much for uh, listening to me till now, and see you later. Thank you very much.